Okay, so a little bit about inverse functions. A linear relation that is described by a function has an inverse function that can generate ordered pairs of the inverse relation. So remember, functions have to pass the vertical line test. Each x value can only go up to or down to one y value at a time. So the inverse function of f of x can be written as that, which it's like a little -1 written as an exponent on the f, but you read it f of x inverse, or the inverse of f of x. So remember, function notation, f of x is the same as y. F inverse is the notation that we're going to use. F to the little -1 of x is the notation we're going to use to indicate the inverse of a function. Okay? Now, if they call the function p of x, or let's say p of r, you know, the y is understood to be like p and the x is understood to be r. The inverse would be p inverse of r, or p of r inverse. Okay? So the inverse function f inverse of x of the linear function f of x, to get that, complete the following steps. So what we're going to do is actually deal with an equation and find the inverse of that equation. So you replace f of x with y in the equation, then you flip-flop the x and y's, solve for y, and then rewrite it in inverse notation with f of x inverse instead of y. So let's find the inverse of this function. So if I have f of x equals 4x minus 8, the first step is to write it as y instead of f of x. Second step is to interchange x and y. So all I'm really doing is flip-flopping the x's and the y's. So anywhere there's an x, I put a y. Anywhere there was a y, I put an x. Then I solve that equation for y. So I would add 8 to both sides and then divide both sides by 4. Now notice I divided this whole side by 4. I'm just going to leave it like that. Then I replace the y with f inverse, and that's the inverse function. Okay? So if I want to check this to see if it actually makes sense, I can graph both functions and the line y equals x and see that the inverse is really the reflection of the original function over the line y equals x, like this. So this blue line is f of x. Notice it has a y-intercept of -8. And if I go up 4 over 1, up 4 over 1, up 4 over 1, up 4 1 over 1 on the slope, I get this line. The graph of x plus 8 over 4, if I plotted some points, would give you this blue line. And notice that the blue lines are reflections of one another. So this point 0, -8 is over here is -8, 0, and so forth and so on. This point 2, 0 is the point 0, 2 right here. So it checks out graphically. How about this one? Let's find the inverse here. So first step, replace f of x with y, then interchange the x and y's, then solve for x. Here what I would do is subtract 11 from both sides and then multiply both sides by -2. Okay, because -2 is going to cancel out the -1/2. So multiply this side by -2. Distribute the -2 and you get y equals -2x plus 22. And then just write it in inverse notation. And that's it. So the inverse of f of x equals -1/2 x plus 11 is f inverse of x equals -2x plus 22. Okay, here's 2 for you to try. Go ahead and pause the video, find the inverse of each of these, and hit play when you're ready. Okay, we're back. So the first one, I'm just going to run through it. Y equals 4x minus 12. Replace, interchange x and y, so x equals 4y minus 12. Add 12 to both sides to solve for y, then divide both sides by 4. So y equals x minus 12 over 4. So f inverse of x equals x minus 12 over 4. And you can leave it like that. If you wanted to write it as 1/4 x minus 3, that's fine. Or x over 4 minus 3, that's fine. Okay. The next one is y equals 1/3 x plus 7. Okay. Replace f of x with y. Interchange the x and y. Then solve for x. Subtract 7. and then multiply both sides by 3. So those cancel, and I'd have 3x minus 21 equals y. So in inverse notation, f inverse of x is 3x minus 21. Okay? Alrighty. So last example, we're actually going to use an inverse function. So remember at the beginning of the lesson, Randall wanted to convert the temperatures from degrees Celsius to Fahrenheit, but all he knew was the equation to get from Fahrenheit to Celsius, but he wanted to go Celsius to Fahrenheit. So we want to find the inverse function. So since c of x is the function notation they're using here, the inverse would be c inverse of x. So I'm going to replace the original function c of x with y, then interchange x and y. Now I wouldn't distribute the 5/9. You could just multiply by the reciprocal of 5/9 to get rid of it. So multiply both sides by 9/5. So that cancels the 5/9 if you do 9/5 here and 9/5 here. So you have 9/5 x equals y minus 32. Add 32 to both sides, and then replace the y with c inverse, and you get the inverse function. So 9/5 x plus 32 is the inverse function. So what do x and c inverse represent in the context of the inverse function? Well, here in the original problem, x represented degrees Fahrenheit and c represented degrees Celsius. We flip-flopped that. So x represents the temperatures in degrees Celsius and c inverse represents the temperatures in degrees Fahrenheit. So find the average temperatures for July in degrees Fahrenheit. So for July, the minimum temperature was 3, the max was 15, but that's degrees Celsius. So I want to find c inverse of 3. So plug 3 in to the inverse equation. Simplify, you get 37.4. So that's the temperature, that's the average low temperature for July is 37.4 degrees Fahrenheit. So if I want the average maximum temperature, plug in 15. Simplify, you get 59. So the average minimum and maximum temperatures for July are 37.4 degrees Fahrenheit and 59 degrees Fahrenheit, respectively. Pretty cool, huh? All right. So here's one for you to try. Peggy rents a car for the day. The total cost, C in dollars, is given by C of X, where the X is the number of miles she drives. So C of X represents total cost in dollars. X represents the miles she drove. Go ahead and hit pause and answer the questions. All right, guys, we are back. So what did you get for C inverse? So for part A, you should have got C inverse of X equals X minus 1999 over 34, or 0.3. Let me fix that. I don't like how that looks. And again, I would leave it like that, X minus 1999, all of that divided by 0.3. B, what do C inverse of X and X represent? Well, in the original problem, C of X represented dollars and X is the number of miles. Okay, so we flip-flop that. If X was the number of miles, on the inverse, that would be total number of miles. And X would represent the total cost in dollars. So C, so how many miles did Peggy drive if her total cost was $34.99? So basically what we're doing is C inverse of $34.99. That's going to be $34.99 minus $19.99 all over 0.3, which is going to be 15 divided by 0.3, which is 50. What would the units on that be? It'd be 50 miles. Okay, you see how the original equation, you input the miles and it outputs the dollars. In the inverse, you input the dollars and it outputs the miles. Okay, guys, so that's inverse functions and relations. Hope you understood all that. Reach out to me if you have any questions. Make sure you continue on down to your assignment and make it a great day. Take care, my mathematicians.